Really would be so much better up there. I'm recording this for students who aren't here. So if you see my laptop set up here, a lot of times it's because I'm recording or maybe I'm getting ready to. It's just recording the screen. So it's no substitute for not being here. Coming to class in Algebra 2 is so essential because I will go over things every day. I don't really like take days off. Maybe during review I'll sit and then you guys work together, but I will teach something every day. So being here is really important. If you're gone, if you're absent, you're not feeling well, there will be a video at the end of the school day that'll show you at least the slides or the board, okay? And you could hear me talk about it. So if you're absent, go to Schoology, pull up the video. If there is no video, send me an email. Well, when there's no video today, or I looked last week, there was no video for that day. And just let me know. Sometimes it doesn't upload. I'm going to do it every day, so sometimes there's a glitch or something. Anyway, this is the 19th, so this would be the third bell work in your binder. And it's being organized by date. When you're absent, you still have to do bell work. So when you're absent, you will pull up the video and you will see the problems on the slide. I will show the answers as well. Or you can get it from somebody in the class if you're absent. Or you can come by after school, Monday or Friday also. So, any questions about that? The video cannot hear you. It can only hear people standing right in front of it. So don't worry, you're not getting recorded. If you walk in front of here, usually if I have a student come up here, I'll hit pause, but not that many people watch them anyway. It's just like some people like it because they're absent a lot. Or if you want to go back and rewatch a lesson because it's a hard day, you can do it then too. But it's very few views, so don't worry about that. Okay. Let's do the box method, or should we? Can I get a volunteer to do either the box method or the FOIL method? A whole group. Jeremy and Maddox, will you guys do either the FOIL or the box method? Which one do you guys like better? Okay, you do the box on this side. And I'll do the other one on the other side. Or Maddox, do you want to do the other one?
Yeah, I can do the other one.
Okay. Let's see if they get the same answer. It's such a fun check when you do the same problem 2 ways to see if the same answer comes out. And then we can talk about it if it doesn't. So much better to see students doing it than your teacher, because a lot of times your teacher does it same way.
We're going to have to put one of these answers, right?
Yeah, only one. Was anybody absent yesterday? Same answer, guys. Great job. Here's our box method answer. You put the first one to the left or up top, whichever. Fill it in just like a Punnett square. Take it out, write it all side by side at the bottom. You know what I think? I think the day we covered maybe we didn't have some students in here for assemblies. Everybody in here remember this?
No, it was the day.
It was there. All right, next, you're going to go to your handout I gave you yesterday, and you were going to highlight step 7. Step 7 is the weirdest step. It's the one that's going to take the most time to get used to. How far did we get in third period? Did we get all the way to step 6? Okay. Step 4, use scrap paper to find two numbers that satisfy both criteria. They must have a product of the top number and a sum of the bottom number. Step 5, fill the numbers in on the side of the X, just like the handout from yesterday. Step 6, this one could also get highlighted, it's weird. Just so you know, if A is 1, if you're writing a 1 in here, you can greatly reduce these steps. These steps are really for when A is something other than 1. But, okay, step 6, you're going to write the A value below the side numbers and reduce the fraction. So you're going to make fractions on the sides and reduce it. And then your binomials, you write the binomials using the denominator as the coefficient of X and the numerator as the constant. So if you want to highlight that and underline the words coefficient and constant. That's a weird step. A little unnatural. And then you can check your answers using the box method or double distribution FOIL. Are we ready for the example?
Yes.
Okay. All right. Here we go. Just blank box for examples. Okay. So step 1. A equals 4. B equals 16. C equals 15. Identify A, B, and C. Step 2. Do A times C. You guys got your calculators out?
Math is easier with calculators. Might as well make it easier.
All right. Step 3. We're going to draw our own. Oh, I don't know why I wrote 16. Thank you. I really had 60 in my mind. Make sure you have a 60 here. I think third period problems. All right. Next step is to draw the X. The 60 goes in the top spot. The 16 goes in the bottom spot. That's the B. And now we have to find numbers that will both multiply to 60 and add to 16. 10 times 6 is 10 plus 6 is 16, so 6 and 10 do work. Yesterday, when you guys did that group handout, that's all you had to do. And now, today, we're going to step 6. Write the A value below the side numbers. So I'm going to go just like that. They become fractions. 10 over 4, 6 over 4. Does it say reduce? Oh yeah, and reduce. And your calculator's reduce for you. So if you don't like reducing fractions, just use the fraction button on your calculator. Did we ever highlight the fraction button on the calculator? Here? I wish we did. If you have your highlighter out, let's highlight it. Yeah, this is, let's highlight it. Let's draw an arrow. Fraction. Life is so much easier with the fraction button, I have to say, because you know what? People hate fractions. So let's just put up the white flag and use our fraction button. And so I don't know how many of you have calculators yet. Back at it. All right, so I'm going to reduce these to, I think what I'll do is I'm going to divide the top and bottom by 2. And I'll end up with 5 over 2. And I'll divide the top and bottom by 2, and I end up with 3 over 2. So these are my numbers. I actually have fractions I have to deal with. 5 over 2 and 3 over 2. And now step 7, the weird one we highlighted. Write the binomials using the denominator as the coefficients of x and the numerator as the constant. Let me just remind you guys, if I'm looking at 5 over 2, the bottom is the denominator, and that'll be the coefficient. And the top is the numerator, and that'll be the constant. So I'm going to take 5 over 2, and I'm going to write it as a binomial, 2x plus 5. And then I'm going to take 3 over 2, write it as a binomial, 2x plus 3. And that's the factored form. Does it look familiar to anybody? What is it?
Oh, the problem you have.
Yeah, it's our problem that we had on the board. So we've already checked this. It is this problem, 2x plus 5 and 2x plus 3. We already distributed this out and got that original problem. Okay, so we just successfully, using the X factor, people call it the power of X, this whole strategy, we successfully worked backwards from standard form to factored form. Okay, lots of ways to do this. Up until this year, I would do something called the A times C method and factor by grouping. Some places before, when I was in school, we did it mental math. We had to guess and check how to create 15 and how to create 4x squared. But this method works really nicely, setting up the x's, a times c, b, and then making the fractions in the middle. The tricky part is going from the fraction to the binomial. So let's practice. Let's do the next example. I'm going to walk through one more, and then I'm going to pause and let you guys work on the back. What did I say? Did I say something? I'm good. Okay. Here we go. Step 1, identify A, B, C. Do it out loud. Do it out loud. Everyone should be doing it out loud. 2, -9, -5. You connect that out loud to your thought, and all of a sudden you're remembering it more quickly. Step 2, A times C. Step 3, build your X factor. Some people are going to struggle and want it to be perfect, but mine's not perfect. Yours doesn't have to be either. It's up to you how perfect your X looks. Okay, and then we'll put the -10 here, -9 here. Any questions so far? And then we got to do the riddle. We need numbers that will multiply to -10 and also add to -9. -10, +1. If you guys ever get stuck, go to winner. Quick at this. Yeah. So if you were thinking 2 times 5, 5 times 2, just remember 1 in the number works. So we're choosing -10 times 1, and -10 plus 1. And yesterday we got to stop here, and today we're gonna keep going. We're trying to rewrite this polynomial. Oh, step 4 is to make a fraction. So I'm gonna put this over 2 and this over 2.
That would be -5 on the left side, 1/2.
Yeah, but you know what? We gotta do yeah, I'm gonna leave it -5 over 1. So that I can move the. Would it just be -5? Yeah, it really would, but step 7 is like the denominator becomes the coefficient and the numerator becomes the constant. So I'm gonna leave that 1 there. We could talk about it more. And then 1 over 2 is just 1 over 2. So boom, here we are, step 7, the doozy. So -5 over 1 gets rewritten as 1x minus 5 because this 1 is the coefficient and -5 is the constant. That's the part that's the hardest part, I think. And then yes, that one is gonna be 2x plus 1. So our answers are x minus 5 times 2x plus 1. And that is a successful rewrite. I could check it. All right, when I check it, I got what I started with. It's equivalent. I feel really good and satisfied that we correctly factored this tricky polynomial. In the end, I like it better than grouping. Anybody else feel like this might be even a little bit better than the grouping thing? The 2 and the 2 and the GCF, give or take. All right, let's flip over. What do we have going on here? Okay. If you recall, the steps say to use scrap paper because this isn't enough space in this little box. So get out a piece of notebook paper to go with this. And I'm just going to stop talking for a few minutes so you can try it together. But I'm going to jump in whenever the time is right. Yep. You may totally use your bell work paper to show your work for your scratch paper. So if you want to keep it rolling right on bell work, you can. Great suggestion, Lily. Yeah. Can you explain just one thing? The only thing I saw is how these turn into about how to go from the fraction to the parentheses, which I do think is the most difficult part. The bottom number goes with x, so I put the 2 next to x. The top number goes second, so it went +1.
Would you always use 2 on that?
Which one are you looking at, Rocco, number 1? Yeah. So you write the A value below the side number. I'm just hearing the best questions. Keep it coming.
X Factor, but I can watch that dance. I'm working on X Factor. Not. Well, I know I'm in
What I don't have yet, what I'm gonna have people put in there, maybe a name set. You know, like put a name set in the pocket. You're really observing something here. I'm not gonna jump in. You're seeing something important. You're seeing patterns and noticing things. All right, I am gonna show one. Does anybody have a request? Which one are you? Or you want me to be quiet? I can be quiet too. Oh wait. Oh wait. Oh wait. I'm gonna do number one. I'll finish this one. I'll give it 10.
Miss, how do you make a number negative?
You hit the negative first.
Oh, first.
Yeah.
Yeah. Thank you.
Ten is a little bit weird. It doesn't have three parts. If you want to rewrite it with a 0 in the middle, you can. It's 1 0. I guess you guys are asking because some people are filling in A, B, C right away. So you know, B and 10 is 0. You can still do the same process. Here's the work for number 1. If you're stuck, please let me know. If you are having a hard time coming up with some numbers, ask the people next to you.